Circle Optics, our mission is to deliver situational intelligence for a safer, smarter, more immersive world. And through our patent stitch-free Parallax panoramic imaging systems, we help defense, aerospace, and robotics professionals improve how they perceive and respond to their environment. At this time, Circle Optics has 18 employees, some interns, and a couple of consultants. We have 23 patents and pending, and are very excited that we're actually beginning to do work outside and beginning our commercialization process. And because of that, it was really exciting for us to begin to think about how do we tell our story, not just with Zach and Ian, our founders and COO, but also the people behind the scenes that are actually putting the optics and mechanics and software together. And this particular segment is with our newest hire, Opto-Mechanical technician Matthew Brophy. And I'm really excited and may even think about how to onboard new employees with that wonderful option to be on a podcast with Jennifer Sertle. But I would like to begin. Welcome to the company, Matt, and thanks for being here.
Oh, thank you.
It's so exciting. How would you describe your role as Opto-Mechanical technician at Circle Optics?
I would describe it as basically pretty much a combination of a test technician. I've had a similar role in the past as an engineering technician, and it's basically the work that I'm doing now is somewhat similar to the type of work that I've done in the past, except for these products are much more custom. I've never seen any lenses like this before, or any sort of camera imaging systems like this either. Some of the alignment processes and steps are a little bit different, but there's a lot of involvement with the technician part, and even some engineering work involved as well too. Definitely a lot of problem solving. A lot of communication. We have meetings pretty much on a daily basis to get updates on what's happening, and then if there's a need for support, there's always a need. There's always an extra hand to step in and give a little bit of support if there's an issue. So it's a pretty tight-knit group of people. So it's not that I'm just doing specifically a assembly or a testing role. It's really pretty much everybody kind of working as a group together too as well. If something doesn't work, basically I'm also trying my best to figure out, okay, how can I get this to work? A lot of troubleshooting involved with these types of tests and experiments that we're trying to do.
What are the skills that you rely on every day?
Definitely a lot of mechanical and optical skills. In order to really determine if there's an issue, you can see, for example, with certain aberrations, depending on how you're trying to test the objective. For example, you can get an indicator off of, okay, you have these aberrations, what's likely to be causing this problem. Sometimes it's more obvious than others. A lot of times we have to kind of consult our optical engineer who has access to the code 5 that can kind of model, maybe certain symptoms that could be going on and kind of point in the right direction of what could be causing this issue. If there's, we say other issues where there's just a slight alignment, or I know that one of our objectives had a tilted element, you could see evidence that there was a big focus shift in that the image quality wasn't very good. I didn't know exactly really what caused it, and eventually heard a shaking element inside an objective. I'm like, okay, well, that kind of explains it. Took it apart and couldn't find out there's an element that just pretty much wasn't powdered all the way on the seat. Had corrected that. The sensor was actually aligned to that objective with a tilted element, for example, and then it had somewhat decent image quality. It was, in comparison to the other lenses, it seemed like the focus was a little bit softer, just off. And then after fixing that, putting the sensor back on it, the sensor was glued onto a plate. You could see that the focus was way off. So, which in a way that's good, because that means that, all right, now it's actually seated properly, and I can realign that and fix that issue, whatever. So there's just a lot of work and troubleshooting. We kind of hope that everything just works smoothly, through the whole process. That, okay, we can assemble the lens, we can test it. We can adjust the compensator. Boom, we're good to go. In a perfect world, that's how things would work. But what makes things challenging and actually in a way interesting to me is that things don't go that way. So
Well,
that's pretty much that's pretty much sums up my role at Circle as a Opto-Mechanical technician.
a lot of, as you were saying the word troubleshooting, a lot of attention to detail. Walk us through your approach to new prototype or assembly.
My approach is to basically do as much research as possible. I know there's certain test equipment that I've never used before. I really wanted to take the time early on and research as much as I can to get a good idea, like how am I going to use this piece of equipment to test this piece of equipment. I know with also imaging the Air Force targets, I've really never tested with that approach too. And we have some pretty good support that kind of help guide me as far as, how to set things up properly, what to look for, and just kind of point me in the right direction as far as like, okay, this is what we're looking to do. This is basically how you can analyze the results you have. So it just gave me just pretty much enough information for me to keep moving forward and kind of point me in the right direction because, like I said before, all these setups are very custom. I've never seen these before. I worked in optics for 20 years, pretty much, and these setups are different. I've never seen setups or lenses that look like this before. But that's also what I find interesting too, because I don't want to be doing the same thing every day, coming to work and just basically just using the same piece of equipment and just kind of pushing things along an assembly line. That's not really the type of work I would like to do. And that's just definitely not it.
Yeah. I was going to say, most of our work so far has been very prototype and very precision-based optics that haven't been built before. So I'm excited that you're actually able, as a new employee, to really see that these systems are very, very different. How do you collaborate with the design engineers during the handoff phase?
They're going to hand off to the next step, like for example, from the optics to the software side, for example. Well, I've only done this once, and I've done it recently, or in the process of handing off. I don't know, this one Prius lens that we're actually working to set up, and right now it's not. The lenses haven't been fully integrated into the headset or the frame yet. But do have a couple set up, and they're just working on pretty much trying to get first light, they call it, through the actual system. And it's more just communication as far as, okay, this is what we have for now. I have it set up here, and I know that with one of the sensors that we're working with as well too, when I started doing some of the sensor alignment, it was just more of the timing of as far as, okay, this lens is going to be ready about this time. We're going to need this software set up and prepared, which the software team worked with us, pretty closely on that. And the timing actually worked out pretty well. And and even on the software side, there's, a lot of their software is also prototype. It's homegrown software. So, their software isn't going to be perfect either the first time through. So it's more of me communicating what my needs are as far as what I need in that software to do, or what type of functionality I require in order to do the testing I need to do. And it's just pretty much just communicating that, okay, this is what I'm noticing. This is a challenge that I'm having. Is there something you can do to help me and help basically make this a little bit more efficient for me to do what I need to do? How do
you balance following documentation with real-time problem solving? Like, is there, it seems like a big toggle. Is it a big toggle?
It is big time. I'm still trying to figure that out. I'm basically just doing it when I can, and that the timing for that and for me to be able to prioritize that in my daily work is a real challenge. I try to give myself a little bit of time to do that before the meetings, because I know a lot of times that they expect the updates and they want to see the documentation, but also they need some of this documentation put on the network, so that basically, I know with the supporting engineer, specifically the optical engineer, needs to know, okay, what was done, what do we have, what did you do to set this up, and they need some good documentation to understand, okay, this is what was done, and here's the results. That way, they can actually analyze the results accurately, knowing the right dimensions and just particulars like that. So that's still a work in progress as far as that balance. I'm doing the best I can with that. I think it's just I'm still fairly new here, so in order to find the time to do that, I have to squeeze in windows of time, say in the morning when I first get settled in. I usually will get in and try to plan my day, and I'll use a little bit of that time to start setting up some documentation or just basically loading images, basically into a PowerPoint, and then basically coming back to them later, and then basically just explaining what was done and adding some details, maybe process some of the data in Excel and make some charts and just add some charts into the pictures, descriptions, whatever the case might be. But that is something that's still a work in progress as far as how I kind of balance the actual hands-on work and the computer work where I'm actually doing the documentation.
I think that's a challenge for all of us. My last question really is regarding what is something about the technician role that other people should understand? And again, what are ways that other team members can be helpful or appreciate more what you're contributing to our success?
I guess as far as this actually sort of relates to the last question a little bit too, as far as what to understand, it's really a lot of it's hands-on. It's not on the computer. I know like a lot of other people do a lot of their design work on the computer. A lot of the engineers, mechanical and optical, for example, software as well too. They're programming a lot on the computer. So that as far as on their end, I believe that they're on the computer more often at the computer, so it might be a little bit easier for them to get their documentation done in a timely manner. But I'm spending probably 80% plus of my time, closer to 90% of my time away from the computer, so that I don't have quite as much time to actually do the documentation. But I understand, I do understand it's been made clear that documentation is very important, so that it's a little bit different dynamic than basically what the rest of the group is doing. And I know that one of our other engineers is kind of taking on some of the responsibilities that I was taking on now. Likewise, I'm sort of taking on some of the responsibilities that he left behind when he had left the company as well too, to try to kind of fill the void. So it's basically I'm seeing there's a need for certain things to be done. Basically, just having certain inventory and communicating that we need certain supplies, for example, in order to keep moving forward, so that we can run some of these tests and we can align some of these sensors to these objectives, for example. Just trying to stay on top of things so that there isn't like a bottleneck or a holdup going forward. Because a lot of the work we're doing, it does take a long time, from what Bob was mentioning, to kind of get everything set up in such a way that everything's done the right way. And I'm trying to do my best to prevent any other holdups or bottlenecks in the process. So it's also sort of like an evolving role too, where I'm sort of seeing a need and I just kind of jump on it and communicate the fact that, okay, this needs to be done, in order to kind of keep things rolling.
One of the first outputs that I saw was just how conscientious you are on what the user outside of Circle would need to see in terms of process and procedures. And so I appreciate that objective eye that's coming in, helping us with some of our documentation, which is great. You have been listening to our Opto-Mechanical technician, Matthew Brophy, and this concludes our Stitchless series on the mechanical team at Circle Optics. Thank you for joining us.